Howdy. How to Get Taken Down by YouTube, Volume 1. That's good enough. Yeah, I want that full screen. Because can't close that if it's full screen. Alrighty. How are we all doing today? Nice to see that the world's not on fire, at least yet. Okie dokie. We should get going. Stayed up late for. I did the same thing. I'm exhausted today. I couldn't stop watching, and I knew it was going to happen too. But hey, that's a good thing. It's never been like this. And the fact that it's still going means that hopefully things are working. Regardless of outcome, everybody voted, which is good. That's what we're supposed to do, right? Okay, so we have 2 more design patterns for you today. These ones are getting, well, I guess maybe 3, depending on how far we get. These get a little bit more complicated, and these are going to be kind of, and not not broader, but a little trickier to implement depending on your language, depending on what you're trying to present. And yeah, they get interesting here. So I'm actually going to show you the visitor pattern in PHP. And no, sorry, the MVC pattern in PHP. Visitor is going to be in Python. We're going to talk about MVC next as well in a little bit more detail than we did last time. But these start getting into kind of interesting areas. So what you get to look forward to today, for a bit of a preamble here, is that we're going to talk about visitor for a little bit, and then we're going to do some group work where you have a in-class assignment due by tomorrow night. Kind of a standard one. I'll have you go to your Discord rooms and chat about something. And yeah, then we'll get into MVC after that. So everything we've been talking about so far has either been, fairly static in nature. Let's set up our classes. Let's figure out how we're instantiating objects in our projects. Now let's start swapping in and out behaviors. And this is where you can really start using the power of some of the object-oriented principles in these languages. So we're going to talk about the visitor pattern. This is a behavioral pattern. Well, I hit down and it skipped a slide here. Let's say that you have a class, and depending on what it is, it might come prepackaged, might be part of a module. Basically, you can't change this base class, but you have to use it and you need to extend it for your particular project. What do? You could either reinvent the wheel and rewrite it, or we can add a visitor pattern to it. So what visitor gets us is basically to add a little bit of extra kind of overhead, kind of wrap extra behavioral capabilities around a class, and then we're going to basically abstract things out so we can swap pieces around. So we want to perform some kind of an operation basically on some kind of a class. So we may have things that aren't built into the structure. We may have operations that we want to add in and they're just not there, or we're going to figure out how to use this class to its fullest potential. Basically, what we're going to do is add this visitor pattern. We're going to separate out our operations into different objects, and then we're going to handle this structure. And that kind of sounds quite nebulous here. Got to call back to an ancient Flash game at this point for the visitor. So how do we do this thing? Basically, every data structure that we have will have an additional visitor class. And we're going to have a specific function that we're going to add to this visitor class that's basically going to get called. So effectively, this particular pattern is adding like a visit function in a way. And I'll show you what this looks like here momentarily. It's going to hopefully become a little bit more clear. What this does is if we need to add new operations, new methods, new anything, it becomes very easy. We just update our visitor class. We can, let's see, let me just kind of pop over here to our to our UML diagram, and then I'll come back. This might be helpful. So what we see here is a UML representation of a visitor class. Now, this is going to look pretty complicated, right? We have some elements, we have visitors, we have concrete visitors, concrete elements. And basically what we're doing is we're just iterating over our data structure, and we are calling this visit function in a way. So effectively, we're going to add an accept function to our class that we're trying to visit, where this particular class is going to accept some operation from another class. So we're basically kind of doing a double dispatch call, if that's familiar to you. Basically, we are calling a super type of function where we are referencing another object. Basically, we're kind of swapping in functionality that wasn't there before. And we're doing it by basically concretizing these additional classes that we're trying to add in. So the client here, I'll check my notes to make sure that I don't miss anything. Basically what we're doing is we're having this client interface and we are adding on the ability to accept other functionalities, if that makes sense. So we're wrapping around this element class, or wrapping, all of our separate structures into these visitor classes. Each of them will have possibly different capabilities. And by accepting any of these visitors, we are accepting the behaviors that they're bringing along with them. If that makes sense. And when you have this concrete visitor 1, concrete visitor 2, these are specializations of a generic visitor class, right? So we may have particular operations happening here, particular operations happening here, and those may be specific to that visitor, right? And then our elements, where we're accepting this visitation, we may have specific concrete elements of this particular element. And this is, again, kind of high-level description right now. We are adding functionality. This functionality may have specific sub-functionalities. Here we have some object with maybe specific instances of that. So why do we do this? We're separating out the algorithm from the object itself, right? This visit function that we're adding in is basically allowing us to kind of swap in behaviors. Go back to that bubble sort example from 1 or 2 classes ago where I said, well, let's start with bubble sort and maybe later on we'll bring in, quick sort or radix sort or any of these sort algorithms, right? Visitor would let you do that simply by bringing in a visitor with a different sorting algorithm. And kind of working backwards here through the slides in a way. So what I guess I'm moving my mouse. What this is doing, interestingly, and I'm trying to highlight this last point under consequences, we're breaking encapsulation by doing this, right? So we have, normally you would encapsulate functionalities like this. All of these, say, sort functions would be baked into our elements, and we might pick one or the other. But here we're kind of breaking things apart. We're breaking that encapsulation, and we're going to allow these visit classes to bring in what they need. And we're going to iterate over them. So let's talk about these classes in a little bit more detail here. So we have our client, right? So client's down here. This is going to be the class that consumes other classes. Basically, it can access all of our data structure elements, right? So the actual static aspects here, and tell them, I need you to accept these visit functions, right? So we can access that structure, and that structure basically is defining an accept, basically we're going to say you need to accept these functions. So that's what client is doing here. Visitor then, we are using that to basically declare that a visit operation exists and allow for specializations, which happens in that concrete visitor. So visitor, concrete visitor, right? So visitor, concrete visitor. If you remember your UML class notation, this is a generalization here. These are basically specializations of some superclass, right? So this is your animal, dog, cat type of example. These might be providing different operations. There might be even different methods or different attributes in there. It just kind of depends on that concrete class. But it's something that has to be implemented separately. Right, so we have these kind of 3 main guys there. And then the other aspect are these visit classes. Now the visitor and concrete visitor are visitable and concrete visitable. The figure doesn't, mouse. There we go. Visitor, concrete visitor, element, concrete element. I guess we don't have the concrete element in there. The visitable is the element from that figure. Basically, in here, we're defining the accept operation. And again, what the accept operation is doing here, sorry, the slides, I realize I pulled kind of a nicer figure from what I had in the slides. This should be visitable, concrete visitable A, visitable B. Basically, we are accepting this other class in here, which is bringing in its methods. So we're going to allow that to come in. It's our entry point. And then the concrete visitable, which again is a specialization of that visitor, or sorry, of that visitable element's a little bit easier to say. we are going to basically accept that operation and then execute it in that regard. So think of it like we're kind of passing functions around in a way. Obviously, it's encapsulated in a class. We're putting that class through to this concrete element, which then would call the accept function. But we're kind of bringing things in. And this is where I said it's kind of getting a little bit more complicated, right? Um, I'm feeling like my description here is not super great, so please let me know if you have any questions. So let's talk maybe about a very contrived example. Let's say that we are setting up classes at a university. So great example for software engineering. We are going to have instructors, professors, which is me. We have students, which are all of you. You and I will have different roles in a class, right? I'm the one teaching the material, I'm grading, I'm bringing in, all of the administrative overhead side of things, and you're all doing homework, you're participating, enrolling, dropping, taking exams, things of that nature. We have different operations that we would perform on a class. Easy enough of a concept, right? We are two, if we modeled you and I as a element, I would be concrete element A, you would be concrete element B. We have specific operations and attributes. Now, if you're trying to tie together classes, so this is figures from this website. They have these kind of made up course names. This would be like CIS350, 641, 2, whatever, 200 something. Here we have 3 separate classes. Now, if we want to tie together these elements, and again, we've set this up in an object-oriented fashion, how do I know which operations are going to be performed by which entity here, right? So if I'm an instructor, okay, I'm going to be setting up the course, putting up the materials, you're going to be enrolling, getting grades, so on and so forth. If you're trying to kind of tie this together at an object-oriented level, and everybody is kind of a class that's floating around in the system, it might be kind of hard to really figure out without like a lot of bad software engineering practices in a way. So like a ton of if statement checks, a ton of flags. Are you an instructor? If you're an instructor, do this. We might start getting classes which are way too tightly coupled, which we haven't really talked about too much, but if you have classes that are so intertwined that updating one makes you update another, that's really bad software engineering design because there's not a lot of maintenance or reuse possibilities. And it gets basically messy to maintain over time. So what we're basically thinking here is that if we have all these separate objects, we want them to be decoupled. We want them to basically be their own entities. Let's have them implement their own operations and just kind of tie them together later on. So does that kind of hopefully make sense? Got a couple examples here to hopefully show you can bring in different algorithms depending on your need. You can bring in different connections between classes. And again, those classes come with methods that we would bring in through this visit operation. We get some nice benefits here out of this as well. And again, this is a complicated concept in a way if you think about it from a programming perspective. Definitely not super easy to explain without really generalizing it. But the really nice thing here is that we have a really nice separation between our objects. So we have this kind of open and close principle where we can very easily add new behaviors without changing the base class, right? So we don't have to change a course class instance if we need to add multiple instructors or TAs or extra students, right? Those classes are all responsible for their own thing. We're update those classes and just kind of bring them in. And then we can also have multiple things added to the same class. So we have a single responsibility here. So again, I'm talking too fast. I'm responsible for myself. You are all responsible for you. I'm not going to have any like dangling methods for taking exams or anything like that, or attending class. I might be giving the class, but I'm not going to be attending, so there's no attendance grade or anything like that. for a school that handled that. So we can basically abstract out as much as we want here, and then these basically concrete entities will be their own kind of atomic unit in a way. Another thing, we can add new entities, right? So here we have instructor and student. Why can't we add a TA, right? Why can't we add a, oh, I don't know who else participates in a class, an adjunct or somebody monitoring the class, or it's the term I'm looking for. Basically, we can add other, say, students or other people type of entities in here where they have completely different impacts on a class. They're still going to get tied to this object, right? So they'll still be tied to what the course is, but it's not going to impact the instructor or the student or the makeup of the actual course. So these are all not going to have to be updated. Every class is responsible for itself, which is lovely. Same here, maybe we add a new type of class. So these are all, let's say, delivered through Twitch, delivered through Zoom, delivered through Blackboard, delivered hybrid. And then maybe we have a new type of class where it's going to be delivered through Second Life or VR or something ridiculous. We don't have to change any of these things because we can just have a concrete instance of this new class type, right? So everything is its own thing. Okay, so there are disadvantages with this too, other than it's complicated to explain and understand. I will definitely admit that readily. We have to update all of the visitors if a class is taken out or added. Basically, we need to know who is participating. So our visitor needs to know all this. And if things are added or removed, the visitor has to be reflected in the visitor as well. It can be difficult to manage too, because if you have a lot of visitors, you have to handle them. It can get kind of messy at times at that visitor level, but again, it's just one area that's messy. Everybody else is nice and clean. And we also can do some data hiding in here as well, right? So SDE, so these, again, class objects, there's a good chance that some of these fields are going to be hidden or private or protected or something like that. And maybe the instructor needs to know something, or the sorting algorithm needs to know something, but it's hidden by the interface. And what do you do to fix that? Well, you either add like a get function, or you change the visibility level if that's okay. But basically, you may need to play around with that a little bit. Just depends on your system. Okay, hopefully it makes sense. When do we use this kind of thing? This turns out to work very nicely with recursion. So if you have like a tree-like structure, so I've got a couple examples here, like an XML or a JSON or a directory tree, or like a linked list, or anything where you have an iteration or a recursion that's happening, rather than doing a for loop and visiting everybody in sequence. You could run through all of your elements recursively, and then whatever data type you're currently looking at would have its own visit operation. Right, so if you have a JSON document, and if you're aware of JSON, you might know that it's not strictly structured unless if you impose a structure on it. So I might have multiple classes which can parse out a particular type of JSON document. Let's go back here. Let's say that these are all represented as JSON objects. So we have a class, a class, a class, a person, but the JSON makeup of these classes might be different, right? Different attributes, different values, different data types. You might have a visitor class which can read each particular document type. Or maybe this one is an XML because it's a legacy system and these are all JSON. Or this one points to an Elasticsearch database instance or something like that. Basically, we have all these different possibilities for adding in functionality here. So if you're iterating over a linked list or a tree, just call the visitor method, and then that will basically tunnel it over to whatever you need. All right, so demo time. I've got a link here to a design pattern in Java website here. So basically, rather than reproduce their code in the slides, I just linked to it. So effectively, this is your JSON or XML data reader. It's actually kind of a, let me make sure that I'm big, this text is big enough here. And you actually see it's the same UML diagram, just a different format. But effectively, you have a list of some kind of an element. And then in this, basically it's a generic document. We have a list of elements in this document. We're going to call the accept function for every single element in this list. And what are these elements? They're XML documents, JSON documents, text documents, whatever you want. So then we're going to add our other element classes, right? So here's a JSON element. It's got an accept function where it calls visit. So basically this is where we're starting to get into that abstraction. And rather than me like going through and explaining all this, I'll let you kind of peruse it if this is something that you want to implement. But what you see when we start breaking things out to a little bit of a higher level, we have effectively a class here which has multiple instances of visit, but it's an overloaded method where it's either an XML element, it's a JSON element, you could add text element, you could add whatever element type you want here. And then rather than saying, looping through this list of documents, figuring out is it an XML, is it JSON, is it text, and then doing all your parsing, here you just say visit XML element, visit JSON element. So basically, it makes things easier at the detriment of being slightly more complicated in a way. So I've got the link to the Java implementation there if you want to play around with it. I'm going to show you the Python one. And I forgot to make my text bigger. Sorry about that. Correct, Abby. I started going to a different camera system, so I was playing around with this visitor. All right, so the Python code that I've got here is basically the visitor example with the professor and the classes and all that. I also have one for visiting flowers and all of that fun stuff too. So we have a class for courses. We have an accept class. Are you teaching? Are you studying? We're going to create our concrete courses, which are these actual classes. We're going to create the classes for the courses. And they're just going to instantiate a something. We'll create a visitor class. And then our concrete visitors are going to implement, I'm saying the word visit too much, but that's the problem with the visitor pattern. Basically, our concrete visitors have a visit function. Our abstract high-level course has an accept function, which basically takes in the visit function of the concrete class. Like I said, kind of complicated. But what we're going to start with, let's create our actual courses. We're going to create the classes which have the visitor in them. We're going to tell each concrete class to accept the visitor's function, and then that's basically the notion of the visitor pattern here. I like this example because it's a little bit more clear which classes are doing what, but the link that I had there is very helpful too if you want to look at it in Java. So concrete class, here's our courses. Our visitors are going to be the people involved. And then we don't care what each of these visitors are bringing in. The course is just going to accept that. Right? So hopefully that makes sense. All right, so now let's run this. Visitor. So all that we're doing here, and it's a little bit small, basically a class is taught by an instructor, a class is studied by a student, or a course is studied by a student. We would do a lot more in there, obviously, right? I'd have functions for grading, I'd have everything that I need to do as an instructor, everything that you need to do as a student. Register, drop, visit class, whatever you have to do. Um, but again, we are just abstracting things out. Can you do this all with a bunch of if statements? Absolutely. But it's a lot messier. And you might look at this and say, this sucks. This is so messy. Why would I ever do this? Keep in mind that if you spend some extra effort at the outset, this is where you start getting nicely elegant programs that are very maintainable. Courses at this university. Teaching, studying, why not auditing? Why not, any other function that you might need? I don't have to update a bunch of other classes. I'm just updating one, maybe two things here. It's very nicely decoupled. So again, great for maintenance, great for reuse. Once you get your head wrapped around the concept, great for basically readability. So yeah, Abby, to your point, you just call visit node. Can you give an industry example of this? That's a good question. An industry example. The Java example honestly was a good one. So let's go back to this website here. And I don't like going to websites in my class, by the way, but this is actually a really good overview. So here the example is that we have to read a bunch of different data types, right? So XML, JSON, whatever you want to do. Consider that maybe you are it's the generic term for Amazon, a web fulfillment online store, I guess. Whatever you do, you have a storefront, and rather than just use something simple like MySQL or a standard SQL server, you need a document database. Okay, because you need very quick access, you need all the lovely things that come with these big data oriented database systems. So MongoDB, CouchDB, Neo4j if you want to go graph based. We don't care. We have a NoSQL database. And if you're familiar with databases, NoSQL means that you don't necessarily have a schema restriction. So I can have a JSON object with any fields that I want in there. I could add in different file types. I can mix and match whatever I want. Now, let's say that we've done this. This is our backend for our entire operation. Depending on what we are presenting to the user or whatever report we're generating, maybe we need this particular set of documents. Maybe it's in a particular JSON format. Or over here, it's an XML because it's on somebody's PC and we have to grab it and read it in. Let's consider this particular example here. Let me zoom in a wee bit more. Again, we're going to get a list of documents. These might be varying data types. XML, JSON, JSON format 1, JSON format 2, whatever we have to do. Rather than iterate through all of them and apply information separately, we can just call their visit function and automatically get whatever information we need out of it. And I'm trying to think of what other examples we might want to do. Let's say that we want to do I don't know, maybe a video game is a good example. Let's cite a video game industry example. I don't know if this is how it was done. I'm just envisioning there's the Shadows of Mordor game, the Lord of the Rings, where you had that nemesis following you around the environment. I haven't played it, but I really liked the development logs for that. I'm pretty certain that the AI would change over time, right? So I think as you accrued, I don't know, anger or something like that, the AI would be different. So you can swap in different artificial intelligence techniques based on where you're at in the game. And you can leave them in as atomic objects. And depending on maybe state or reputation level, the visit pattern calls this particular AI algorithm. Just be another example. Does that kind of make sense? Think of it like you're trying to add in things where you don't have the ability to change the basics in a way. That's pretty bad for PS3. I never played it. I heard it was a great game though. But let me go back to the very beginning here. In a way, it kind of is polymorphism. And a lot of these techniques will take that into account too. Or they're going to use those as, is that a correct association? Yeah, I could see that. Um, like I said, it's using something called double dispatch in object-oriented programming, which basically we're referencing a reference. Polymorphism scares me. That's good. It should scare you. Not good to change the base. It's good to not change. Yeah. So yeah, the base class is there, and you need to add on extra capabilities. And maybe it's not a game or an AI, but you download say you download a library, or you're including a module, and you want to extend it, or add in functionalities that aren't there. This would be one way to do that. Basically, you wrap a visitor class around it and instruct it to accept all these other operations. Polymorphism is basically that we are allowing things to be represented differently. A simple example would be like a friend function in C or an overloaded function where calling visit does the same thing just depending on the circumstance, or calling visit does different things depending on the circumstances. Simpler, I guess, example of that. But yeah, this is where things start getting a little bit more complicated, and you can actually see that in the UML diagram here. And I'm getting a ton of emails. Something must be going on. All right, so that was our demo for this. I've got a link to Java. I've got Python code, which I forgot to upload it again. I will do that during my office hours today. You can do this in C as well, using function pointers. So if let me see it just for funsies, since I think I want to end on our little in-class assignment, perhaps. Function pointer C. See if we can get a nice visual here. Oh, we're not going to get a good visual. I love function pointers. They're so messy. No, not a YouTube link. Go away. No, stop. All right. Let's see if we can get in here. So are all these classes requiring methods to be implemented? Yes, so we do need accept methods, we need visit methods, and we need there to be a link between them. So yes, that's a good question. This is not a... Okay, so maybe this is a good example. So here's a function. I keep talking about function pointers, and I know that probably 7/8 of you have no idea what I'm talking about. Here you have a program, say a C program or even a Java program. You have a function call. That function call will point to a memory location somewhere, right? So it's going to be machine code, more likely hex code that you would pick out of it. And you have a list of instructions that happen from that address. Now the function pointer is basically getting this reference and saying execute the code starting here. So in C, you could actually be cute with something like this. And you can say, well, instead of calling this function pointer, call this one. And then you're pointing to a completely different visit method, effectively. So that is where we are at with function pointers. So I guess, Kyle, to your question, it is fairly stringent in what you have to do. So you do need this kind of a representation here. Maybe you don't need to generalize out the visitor as much if it's a more simple problem, but you need the accept function, you need the visit function, you need the client to be aware of that. All right, so what we can do now is let's get to the fun part. So what I'd like you to do now for, say, the next 10 minutes is, let me get over to Discord here. Up, up, up. Please drag, thank you. Do you think the visitor pattern works better for C or Java? So the visitor pattern is going to work regardless of your language. It's going to be easier in Java. In C, it's going to be trickier. And the reason why, and it's going to be the same for C# and Python, it'll be easier when you have all of these nice object-oriented structures to play with. If you're doing it in C, you have to manage all your memory by hand. And it gets very, very messy. So working better, I guess, depending on your perspective. It's easier to implement in Java, let's put it that way. So rather than have you all do something for your term project, let's do a slightly different take on things here. So I want you all to pretend like you're making a phone application. Android, Java, or Android, Kotlin, Apple, I don't care. It's going to be a social media application where you can manage every single one of your multiplayer game characters across all of your multiplayer games that you have. This is an amazing feat of technology because somehow you have API access to World of Warcraft, to every single multiplayer game out there. You load it, it pulls data from each game and shows your avatar, your inventory, and your stats, and then you can min-max your character to your heart's content. So if you're playing Diablo 2 or 3, or an MMO, or anything where basically you can pick, mix and match stats, and inventory items, and armor, and all that fun stuff. Amazing application. I've seen these for like single games, but not cross-platform games. That's what makes it world-changing. So, Diablo, hey, there we go. We all have phones, right? It's the joke. Okay. So pick a random room in the, exactly, group 1, 2, 3, or 4. So join a room and talk about a use case. So you don't have to make a UML diagram, but give me kind of a high-level use case example for how you might implement an observer pattern, how you might implement a visitor pattern. So what would the use case be? And if you're not sure what I'm looking at, what feature in this application would necessitate an observer? What would necessitate a visitor? And remember, observer from before is where you have a subject and it notifies everybody watching you. Make sense? So, join group 1, 2, 3, or 4. Come up with a couple examples here. Submit with everybody's name, since I'm just letting you randomly shuffle. And then, if we have time, we'll talk about it, but that's probably going to be it, I guess. Make sense? To cue the elevator music. Literally. I'm not surprised there's actually an elevator music YouTube video. Don't want to show this on stream, so that's there we go. I don't want to break any privacy laws here. This is oddly hypnotic. This music is making me giggle, I'm sorry. I'm sure you've all muted me by now. How we all doing? Looking good. Unfortunately, I haven't muted. Yep. Since we have a couple more minutes here, make sure that you all write down your names on your submission so I can grade them appropriately. Player stats. Creating each character. Cool. Got some just kind of reading over your responses in the channels and seeing some good good ideas here. Alright, you all have 1 more minute of this lovely elevator music. Alrighty. Well, I've got 50 minutes of elevator music left, so listen to that during my office hours if I forget to turn it off. Okay, you all have a wonderful afternoon. Be safe out there. Hopefully it doesn't get too crazy. And have a wonderful day. 10 experience. You know, I legitimately considered just wearing it on Monday and not saying anything about it. Wear the lobster hat more. I will take that into consideration. Makes software engineering more exciting. Awesome. All right, thanks everybody. This has been fun. Next time we'll talk about MVC and MVP, and it will be fun on the bun. Bye everybody.